Good day, student. My name is Cyril, and today we'll be looking at NEET Physics past questions for 2025. So let's dive right into it. The first question says, a charged particle enters a magnetic field at right angles to its velocity. What is the path followed? Now, when a charged particle enters a magnetic field perpendicularly, the particle tends to move in a circular path. Why? Because there is a force of what? A centripetal magnetic force that is what going to pull that particular particle such that it moves in a circular path. So they're asking, what is the path followed? The path followed is what? A circle, which is option B. So that takes us to question number 2. Question number 2 says, what is the SI unit of magnetic field strength? What is the SI unit of magnetic field strength? The SI unit of magnetic field strength is Tesla. And 1 Tesla is equals to 1 Weber per meter square. So that takes us to question number 3. Question number 3 says, a 2-meter long wire has resistance 5 ohms. If stretched to double its length, its new resistance becomes what? So looking at this question, it involves us to calculate. So in this question, we have given the length as 2 meters and we're given the resistance as 5 ohms. Then it said that this length is doubled. So we have our L2. L2 here is twice the original length, which is 4 meters. Then it said what it is new resistance, R2 we do not know. Please know that the resistance is directly proportional to the square of your length. So if that is the case, it means that my R is equals to KL squared, which is similar to saying that my K is equals to R over L squared. So if I impute this means that I have what? R1 over L1 squared is equal to R2 over L2 squared. So if I impute my values, automatically this means that my R1 here is 5, so I have 5 over my L1 is 2, that's 2 squared is equals to, this is R2 over my L2 is 4, so I have 4 squared. So this will give me 5 over 4 is equals to R2 over 16. So if I cross multiply, I will have 4R2 is equals to 80. So I divide both sides by 4 divided by 4, it means that my R2 is equals to 20 ohms. So looking at our option, the correct answer to this question is option B, which is what? 20 ohms. So moving on to question number 4, it says that in a photoelectric experiment, increasing the intensity of light will increase what? Now, when in a photoelectric experiment, when you increase the intensity is going to increase the amount of photons that will be hitting the metal. And when the amount of photons hitting the metals increases, automatically we'll be having what? Increase in photoelectrons. So what is going to increase there is the photoelectrons. So according to this question, if you look at our option A says we have what? Increased kinetic energy of the photoelectrons, which is wrong. That we are going to have increase in frequency, threshold frequency, wrong. We are going to have increase in work function, which is wrong. We are going to have increase in the number of emitted photoelectrons, which is the correct answer. So the correct answer to this question number 4 is option D, which is what? Increase in the number of emitted photoelectrons. Moving on to question number 5, it says time period of a simple pendulum depends on what? So the time period of a simple pendulum, according to the formula for simple harmonic motion, we say that what? Period is equals to 2 pi square root of L over G. So this simply means that the period of a simple pendulum depends solely on the length of the string. The length of the string is the what? The property that determines the what? The period of a simple pendulum, and that is what? Option B. So that takes us to question number 6, which says what quantity is conserved in an elastic collision? In an elastic collision, both momentum and kinetic energy are conserved. Both momentum and kinetic energy are conserved. So in this option, we have what? A, momentum, B, we have kinetic energy, and C, we have both A and B, and D, we have only energy. So the correct answer to this question is option C, which is what? Both A and B, which is what? Both momentum and kinetic energy. So that takes us to question number 7, which says a capacitor is fully charged by a DC source. What is the current through it? Now, whenever a capacitor is fully charged, there is zero current flowing through it. Why? The capacitor is not fully charged and there is no more current flowing through it. So the current flowing through it when it is fully charged is zero. So the correct answer to this question here is A. So there is zero current flowing through it as it is fully charged. Question number 8 says, what is the energy stored in a capacitor of capacitance C charged to voltage V? What they're simply asking you is, what is the formula for calculating the work done on a capacitor? And we know that the work done in any capacitor, work done in a capacitor or energy stored in a capacitor is equal to half CV squared. The product of the capacitance times the voltage, half of it. This will give you what? The formula for calculating the work done in a capacitor. So we're looking for the what? Correct answer to this question. So looking at our option here, it means that our correct answer is option B. So question number 9, which is the next question, says, which law governs the magnetic field around a current carrying wire? The law that governs the magnetic field around the current carrying wire is Ampere's law, which relates the magnetic field in a loop to the current passing through the loop. It relates the magnetic field in a loop to the current passing through the loop. So the correct answer to this question number 9 is Ampere's law, which is option D. So that takes us to question number 10, which says the work done in moving a charge in a uniform electric field is dash. The work done in moving a charge in a uniform electric field is that an electric field, first of all, it is conservative, and because it is conservative, it is independent of paths. So it does not depend on the path. So because of that, because the work done in an electric field is independent of path, so it means that the work done in moving a charge in a uniform electric field is also independent of path, which is what? The correct answer to this question is option C. Moving on to question number 11, it says the dimensional formula for Planck's constant is dash. So we know that the energy is equal to Planck's constant times the frequency of the electromagnetic spectrum. So this means that Planck's constant is equal to energy over the frequency. But we already know that the frequency is 1 over period, which is similar to saying that Planck's constant is equal to energy times, this is divided by 1 over period, which is the same as saying energy times period. So it means that my Planck's constant is the energy times the period. So we're trying to find the dimension, and we know that energy is force times distance. So this means that I have what? Force times distance times time. And since this is what I have, and I know that my force is mass times acceleration, so I have what? Mass times acceleration times distance times the period, which is what? Time. So with this, we know that our dimension, therefore, is mass times our acceleration is length per time squared times my distance is length, and this is times time. So this means that I have my dimension to be m times L over T times L times T. So this T will cancel out this T. It means I have what? M L squared times 1 over T, which is the same as saying that I have M L squared per time. So we're looking for the dimension that has this format, M L squared. So I have M L squared per time. So the dimension for Planck's constant is ml raised to power 2 per time. So that is option B, as in this case. So that takes us to question number 12, which says an object moves in a circle with constant speed. Which of the following is true? So when an object moves in a circular path, we know that what? The speed is constant, but the velocity is not constant. Why? Because as it is moving around the circular path, it is constantly changing direction. So, and we know that speed is what? A scalar quantity hence direction is not needed. But velocity is not constant because it is a vector quantity that is involved what? Direction. And the acceleration is not zero, but instead the acceleration is towards the center of that circular path. So the correct answer to the question number 12 is option C, which is what? Acceleration is towards the center. So that takes us to question number 13. Question number 13 says, which wave has the highest frequency in the electromagnetic spectrum? In the electromagnetic spectrum, in the EM spectrum, we discovered that what? The gamma rays have the highest frequency in the what? Electromagnetic spectrum, which is option D. Option D, which is what? Gamma rays. So question number 14 says, the SI unit of electric potential is dash. The SI unit of electric potential is volts. The SI unit of the electric potential is volt, which is what? Option B. Option B is the SI unit, which is volt. That takes us to question number 15, which says the focal length of a plane mirror is dash. The focal length of a plane mirror is dash. Please know that a plane mirror does not diverge and does not converge. And because it does not diverge or converge, automatically it means that its focal length is infinite. There is no end. So the correct answer to that question is B, which means that the focal length of a plane mirror is infinite, which is option B. So that is also question number 16, which says, which of the following is not a unit of power? Which of the following is not a unit of power? If you look at all the options, the first option here, watts. Watt is a unit of power. Joules per second can also be written as watts because power is talking about what? Energy over time. And joules here is the unit of energy, and seconds here is what? The unit of time. So joules per second is also what? A unit of power. Kilowatt is just an expression of watt in multiple. So that is also a unit of power. But Newton per second is not a unit of power because Newton per second is simply saying what? Force over time. And force over time is not the formula for calculating power. So the answer to this question is option C, which is what? Newton per second. It is not a unit of power. So that takes us to question number 17. We said Kirchhoff's second law is based on what? Kirchhoff's second law is based on what? So Kirchhoff's second law is based on conservation of energy. So Kirchhoff stated the second law, and it is based on conservation of energy, not conservation of mass, not conservation of charge, neither is it conservation of momentum, but it is based on conservation of energy, which is option A. So that is also question number 18, which says, which of the following can be used to produce electric current? Which of the following can be used to produce electric current? We can use your battery to produce electric current. We can use a generator to produce electric current. We can also use a thermocouple to produce electric current. So the correct answer to this question is all of the above. We can use everything here to produce electric current. So which is option D. All of the above can be used to produce electric current. Question number 19, which is the next question, says, which physical quantity has a unit Newton per meter? Sorry, Newton meter. Which physical quantity has a unit Newton meter? Newton is the unit of force, and meter here is the unit of length or distance. So looking at this, the first one here, option A, says walk. Walk is force times distance, which is what? Newton meter. Torque is also what? Force times distance, which is also Newton meter. Energy is also force times distance, which is also what? Newton meter. So all of the above has the unit Newton meter. So the correct answer to this question is option D, which is all of the above. So question number 20, which is the next question, says the magnetic flux through a surface is maximum when the magnetic field is dash. Now, in a magnetic field, whenever the magnetic field is perpendicular to the surface, then the magnetic flux is always maximum. It will get to its maximum whenever that the magnetic field is perpendicular to the surface because of its formula, which says what? Fd cos theta. So because of this, It means that what? The magnetic flux will be what? Maximum whenever the magnetic field is perpendicular to its surface. So the correct answer to question number 20 is option B, perpendicular to the surface. Moving on to question number 21, it says, what happens to the current if resistance is doubled and voltage is halved? Now we know from Ohm's law that V is equals to IR, which means that my I, which is current, is equals to V over R. So what they're saying is that what happens to the current if the resistance is doubled? So it means that my current, my resistance is doubled and my voltage is half, which means that my V is now what? V over 2. This is divided, my resistance is now what? Doubled, which is 2R. This is the same as in I have V over 2 times 1 over 2R, which means I have what? V over 4R, which is the same as saying that I have 1 over 4 V over R. And we know that originally that my current is what? V over R. So if I'm having 1 over 4 V over R, it means I'm having what? 1/4 of what I had before. So what happens to the current if resistance is doubled and voltage is half? It means that the current will become what? 1/4. So the current becomes 1/4, which is what? Option D. So that takes us to question number 22. Question number 22 says, the frequency of an AC mains in India is dash. Please note that the frequency of an AC mains in India is 50 Hz under normal circumstances, under standard voltage of 230 volts. It is what? 50 Hz. In Nigeria, your frequency of your AC mains is between 49.75 Hz and 50.25 Hz. Why? Because our current fluctuate, our voltage fluctuate between 230 and 240 volts. So that is also question number 23, which says, if a body is in free fall, its acceleration is dash. Please note that when a body is in free fall, its acceleration is constant. Its acceleration is constant. Why? Because it is falling freely. So the acceleration is constant, and that is option A. So that is also question number 24, which says, what is the unit of resistivity? What is the unit of resistivity? The unit of resistivity is ohms meter, because we know that resistivity is RA over L, which is the same as saying that my R here is ohms, so I have ohms times my A here is area, which is meter square divided by meter. So this meter here will cancel this square, so I have what? Ohms meter. So it means that my resistivity is ohms meter, which is option A. So that takes us to question number 25, which says, in which phenomenon is total internal reflection used? Please note that total internal reflection is not applicable in the telescope. It is not applicable in the periscope. It is applicable in optical fibers. So your optical fibers makes use of what? Total internal reflection, which is option C. So option C is the correct answer to question number 25. So that takes us to question number 26, which says, what is the work done by a centripetal force? A centripetal force does not do any work. Why? Because for a body to be experiencing centripetal force, it means that it must be having a perpendicular distance from its surface. So automatically it means that the centripetal force, the work done by centripetal force here is 0. So the correct answer to this question is 0, which is what? A. So that is to question number 27. We say, what radiation has no charge and has no mass? The radiation that has no charge and has no mass is gamma rays. Gamma rays have no charge and they also have no mass, which is option C. So question number 28, which is the next question, says, at resonance, your LCR circuit, which is your inductor, your capacitor, and your resistor circuit, the impedance is dash. Please note that at resonance, we already established that your capacitive reactance is equal to your inductive reactance. So your capacitive reactance, SC, is equal to your inductive reactance, SL. So when they are equal, it means that I'll be having only the reactance from the resistance. So from the resistor, I will only be having what? Resistance. And at that point, since my impedance will only be including that of the resistance, it means that my impedance will be minimum. That is the least amount of impedance I can have, which means that at resonance, I'm having what? Minimum impedance. So which is option B. So that is also question number 29, which says, what type of lens is used to correct myopia? Please note that myopia is corrected using a concave lens. Myopia is corrected using a concave lens. Myopia is simply nearsightedness, and we use what? A concave lens to correct it, which is option B. So that is also question number 30. Question number 30 says, the range of projectile is maximum at an angle of dash. The range of projectile is maximum at an angle of dash. And we know that our range in projectile motion is u squared sine 2 theta over g. And this can only be maximum if the angle of projection is 45 degrees, because this means I'll be having u squared sine 2 open bracket 45 over g, which is same as saying I have u squared sine 90 over g, and sine 90 is 1. So at this point, everything here times 1 will give me the highest amount of range that I can possibly have, as sine 90 is the highest form that you can get any sign of angles to be in. So the range of projectile is maximum at an angle of 45, which is option B. So that is also question number 31. Question number 31. Question number 31 says, the unit of electric charge is dash. The unit of electric charge is dash. The unit of electric charge is Coulomb, named after Sir Coulomb. So that is option B. The unit of electric charge is Coulomb. So question number 32, which is the next question, says, in an elastic collision between two bodies, which of the following is conserved? I explained earlier that in an elastic collision, both energy and momentum are conserved. So both energy and momentum are conserved in an elastic collision, which is option C. So moving on to question number 33, it says the escape velocity from Earth depends on dash. So for you to get what it depends on, you just need to know the formula for escape velocity. We know that escape velocity V is equals to square root of 2gm over r. And from this, we know that our g is a constant, which is 6.67 times 10 per minus 11 Newton meter square per kilogram square, which is Newton's constant. M here is talking about mass, and this is talking about what? Radius. It means that what? The escape velocity of Earth depends on the mass of the Earth and the radius of the Earth from our formula. So the correct answer to this question is option C, which says what? Mass and radius of the Earth. So that is also question number 34, which says the maximum number of spectral lines emitted when an electron drops from 5th to 1st level is dash. Please note that for you to calculate the number or maximum number of spectral lines, our formula is n open bracket n minus 1 divided by 2. And since I'm talking about what from the 5th line, it means what I'll be having, my n here is 5, so I have what? 5 open bracket 5 minus 1 divided by 2, and that will give me 5 times 4 over 2, which will give me 10. It means that the maximum number of spectral lines emitted by an electron drop from the 5th to the 1st level here is going to give me what? 10. That's the number of what? Spectral lines, which is option A. So that is also question number 35, which says, which of these is a vector quantity? Which of these is a vector quantity? The first option here, walk, is not a vector quantity as it does not involve direction. Distance is not a vector quantity, it also does not involve direction. Energy is also not a vector quantity because it does not involve direction. But electric field involves direction, so it is a vector quantity because it has both magnitude and direction. So that is option C. Moving on to question number 36, it says, the electric field at the surface of a charged conductor is dash. Please note that whenever a conductor is charged, the electric field at the surface is the strongest, especially at its pointed end. At any pointed edges, you have more of the electric field present. So you have more of the electric field strength present at the surface and at pointed end. So at the surface of a charged body, we have what? Maximum of that electric field. So the electric field is what? Maximum at the surface. So that's option C. So question number 37, which is the next question, says, what is the dimensional formula of force? What is the dimensional formula of force? And we know that force is equals to mass times acceleration. This is the same as saying that since we know that acceleration is velocity over time, and velocity is displacement over time, which means that my acceleration is displacement over time squared. So with this, we know that our force is mass times displacement over time squared. So we know that dimension therefore is mass times my displacement is measured in length over time squared, which is the same as saying that my what? My force therefore is ml per time squared. So I have what? ml per time squared, which is what? Option A. ml per time squared, which is option A here. That is what? Dimensional formula of force. So the next question, which is question number 38, says, which instrument is used to measure pressure? Option A, we have thermometer. Option B, we have ammeter. Option C, we have manometer. And option D, we have voltmeter. The thermometer is used for measuring temperature. The ammeter is used for measuring current. The voltmeter is used for measuring voltage. The manometer is used for measuring pressure, which is option C. So the correct answer to question number 38 is option C, which is the word manometer. So that is also question number 39, which says, a transformer works on the principle of dash. A transformer works on the principle of dash. A transformer works on the principle of electromagnetic induction, which is otherwise also known as mutual induction, as in this case. So the correct answer to this question is option B, which is what? Mutual induction. So your transformer works with what? Mutual induction, which is option B. So that is also question number 40. Moving on to question number 40, which says, in Young's double slit experiment, the fringe width increases if dash. Now we know that from Young's double slit experiment that our fringe width is inversely proportional to the distance of separation, which means that when the fringe width increases, the distance of separation reduces or decreases. So in Young's double slit experiment, the fringe width increases if the slit separation decreases, which is option C, option A here. Option A says the slit separation decreases. So when our slit separation D decreases, it means that my what? Fringe width is increasing. So if my fringe width decreases, it means that my what? Slit separation is increasing. So they are what? Inversely proportional to themselves. So the correct answer to question number 40 is option A. So that is also question number 41, which says, what is the potential energy stored in a stretched spring? So what they are simply asking you is that, what is the work done on a spring, on a stretched spring? And we know that the work done or the energy stored in a stretched spring is half kx squared, or you can simply say half ke squared, as E here is talking about extension, same as what? X. So K here is the constant, and E here is talking about what? The extension. So the correct answer to this question is option A, which says what? Half kx squared. Moving on, that takes us to question number 42, which says, what is the dimensional formula of Planck's constant? And we know that E is equals to hv, and that means that my Planck's constant H is equals to E over V. And we know that our V, which is electromagnetic frequency, is equal to 1 over T. This is same as saying that my H is equals to ET. And if that is what I have, we know that our energy here is force times distance So we have force times distance times time. This is the same thing as saying that I have my Planck's constant to be equals to, my force here is mass times acceleration times distance times time, which is the same thing as saying that I have mass times my acceleration is length over time squared times this distance here is length, this is times time. So my time square will cancel this time from here, so I have mass times length squared per time. So it means that my dimensional formula is ml raised to power 2 per time, which is what? Option A. ml raised to power 2 per time. That is option A. So that is also question number 43, which says, what happens to capacitance if distance between plates is doubled? Please note that the capacitance is inversely proportional to the distance between plates, which means that if the capacitance is 1, if the capacitance is increasing, it means that the distance between the plate is what? Reducing. So according to this question, what happens to the capacitance if the distance between the plate is doubled? If the distance between the plate is doubled, the capacitance will be halved. Why? Because if this becomes 2, this will become what? 1. If this becomes 1, this will become 2. So whenever the distance between the plate is doubled, it means that the capacitance will be halved. In this case, that is what? Option B. The capacitance will be halved if the distance between the plate is doubled, as they are what? Inversely proportional. So that is also question number 44, which says, in Boy's model, the angular momentum is quantized as, they're simply asking you that what is the formula for the angular momentum in Boy's model? In Boy's model, the angular momentum is equals to nh over 2 pi. This is the formula for calculating the angular momentum in Boy's model, where n is representing our principal quantum number and h is representing Planck's constant. So the correct answer to this question here is option C, which is what? nh over 2 pi. So that is also question number 45, which says, which material is used in fuse wire? Now, in your fuse wire, we use materials that can easily melt, that have low melting point. And the material that is used in fuse wire is lead tin alloy. So when you have a lead tin alloy, a combination of lead and tin combined together that can easily melt is what is used in your fuse wire. So the correct answer to this question is option B. So that takes us to question number 46, which says, which property of light proves it is a transverse wave? Now, there's a property of wave that distinguishes transverse wave from longitudinal wave, and that property of wave is polarization. Only transverse wave can be polarized. Longitudinal wave cannot be polarized. So in this question, which property of light proves it is a transverse wave is polarization, which is option D. Light can be what? Plane polarized, which is option D, polarization. So that is also question number 47, which says, what is the acceleration of a body moving in a straight line with constant velocity? So long as velocity is not changing, whenever velocity is constant, the acceleration is always 0, because acceleration is simply the rate of change of velocity. So if there is no change in velocity, it means there will be no acceleration. So the correct answer to that question is B, which is what? 0. So question number 48, which is the next question, says, what is the unit of magnetic flux? Magnetic flux is a fundamental quantity measured in Weber. So the correct answer to that question is Weber. So that takes us to question number 49, which says, which particle has the least mass? Which particle has the least mass? The particle that has the least mass is the electron. Electron has a very small, almost insignificant mass. So the correct answer to that question is option C, which is what? Electron. And then question number 50 says, what is the ratio of electric to magnetic field in EM wave? What is the ratio of electric to magnetic field in EM wave? Please note that the ratio of electric to magnetic field in EM wave is the speed of light. The speed of light, which is what? C. And that is the correct answer to that question is option A. So we have come to the end of today's class. If you have any question, drop it in the comment section. Please don't forget to subscribe and turn on your notification bell so that when we drop videos like this, you will be notified. Thank you.